Welcome. All right, so in this case, what I have is 2x plus 3y equals negative 6, and 3x minus 4y equals 25. And the idea that we're trying to get across here is we want to be able to eliminate one of our variables, x or y. And this one, it's kind of like a grab bag, really. I mean, to do this, we got to have the same coefficient either for our x or either for our y. And one can be positive, one can be negative, or they can both be positive and both be negative. It doesn't really matter because we can still solve it either way. But you can see here, 2 and 3, the common denominator or the common multiple for 2 and 3 is 6. And here, the common multiple is 12. Either way, I'm going to have to multiply both equations by the other number to get my common multiple. So, it's not really going to be easier for solving for x than it is for y, or for y than x. However, I would say that if I only have to multiply by 3 and 2 rather than by 3 and 4, that might make the problem a little bit easier. So what I'm going to do is I'm going to solve for x. And therefore, I need to get my variables to be exactly the same. So to do that, I'm going to multiply the top equation by 3 and my bottom equation by 2. And remember, when you're multiplying your equation by multipliers, you got to multiply every single term by that multiplier. So therefore, 3 times 2x, right, distributive property. So 3 times 2x is 6x plus 9y equals negative 18. 2 times 3x is 6x. 2 times negative 4 is going to be negative 8y. 2 times 25 equals 50. OK, so now I have my two equations with the same variable. Now, since they're both positive, I'm going to want to solve my system by subtracting the equations. Because again, remember, our idea is to eliminate one of our variables. So to eliminate a variable, we got to get 0 as the coefficient. So I'm going to subtract the two equations. Now, what's very helpful a lot of times when subtracting is rather than saying out loud, I just like to apply division to every single term. So it's going to be negative 6x, positive 8y, minus 50. So then what I did is I just did the opposite of every single term. Now I can add them. So a lot of times when subtracting, it's just easier to multiply by negative 1 and then add them. So 6x plus negative 6x is, so that's a negative. So then I add. So I did the opposite of every term, and now I'm going to go back to addition. So 6x minus 6x is 0x. 9y plus 18y is going to be 17y equals negative 18 plus a negative 50 is going to be a negative 68. Now you can see the 0 is no longer there because it's been multiplied by, or the x is no longer been multiplied by 0. And then I solve for y, so I divide by 17 on both sides. And therefore, y equals negative 4. All right. So now I know the value of y. So these two equations are equal at the value of y. Now I need to figure out, well, what is the value of x? So to do that, I need to take the value of my y and plug it into one of these equations. It doesn't really matter which one you plug it into. Preferably the one with the smaller or no fractions would probably be preferred. So then I'll just take 2x plus 3y equals negative 6. Now I'm going to take my value for y and plug it into this equation. So I have 2x plus 3 times negative 4 equals negative 6. 2x minus 12 equals negative 6. And 2x equals positive 6. Divide by 2, x equals 3. So therefore, ladies and gentlemen, the solution to this systems of equation is x equals 3 and y equals negative 4. Thanks.